Yo, what's up, everyone? Welcome back to the second lesson, and sorry for the slight delay on it. I've definitely been kind of struggling to adjust back to this cycle, um, and I want to make sure I'm giving really good lessons. So I haven't been totally on top of it, but I'm pretty sure after this week I'm going to be good. So I really appreciate you for bearing with me as we get settled and figure out this online madness and the crazy world. So I'm doing it on a piece of paper again, but you can also do it on a piece of paper, or you could print out the worksheet, and once you finish, just upload it to your Google Drive. That's all you have to do. So, with all that being said, I'm just going to get into the question. I'm pretty excited about the lesson today because this year for Algebra 2, we're going to kind of do a lot of like applying of the work. So I don't want to just, figure out how to solve equations, do basic algebra 2 stuff necessarily. I want to talk about how to actually apply it to the real world and also get us thinking about how to think in math. So yeah, anyway, okay, let me read the first question. I'm only going to go over two questions, and then you only have to work on questions today, but each question is kind of lengthy. But it's all review. We're still in stuff that should be review, and we're doing easy stuff to start so that when we have to do these skills again, everything builds on everything else. So when it gets harder, we'll have already done some easier examples. So yeah, maybe I rambled too much in the beginning, but let's get into it. Um, it says you work a part-time job at In-N-Out, which pays you $15 an hour. If you start with $50 in your bank account, create a linear equation to model how much money you have as a function of how many hours you work. So we're going to basically graph and figure out how much money you would have in this scenario based on how many hours you work, right? So the first thing it asks us to do is just identify the variables. Okay, so the key to think about here is that we have two things going on, an input and an output. And this is always how equations work, and this is a pretty straightforward example of it, but we know that you are going to work some number of hours, and the number of hours you work is going to, okay, so um, we're talking about figuring out how we can make an equation for this word problem, and the key to this is to think what our variables are and how they relate to each other. Okay, so if we were just, before we even talk about the variables, if we were to think, if you work more hours, you're going to get paid more money, right? So both of them go up at the same time. But whenever you're trying to work out an equation, you want to figure out what is depending on what. So if it's asking us what the independent variable and the dependent variable is, we have to think that the amount of money you make is dependent on how much, how many hours you work, right? So x in this case, which is the bottom of the graph, right? So we first are traveling, right? We're going to work a certain number of hours, and then our goal is going to be the dependent variable, which is y. Sometimes my handwriting is awful. That's a W. Hours worked, not worked. And money. And we know that they go up at the same time. And this is not always going to be the case, but these are our two variables. And now we're trying to figure out how we can create a linear equation for those two variables. Okay, so it's giving us a hint here that we're going to start in y equals mx plus b. And we have to figure out what the slope of this line is going to be, and then what the y-intercept is. Okay, so first let's talk about what's given to us. It says that we get paid $15 per hour. Okay, so if we know that x is the number of hours we work, the slope is just going to say, if we put a 15 here, that if we work 1 hour we get $15, but if we work 2 hours we multiply 2 to 15. Okay, so the slope is always telling us how much we're increasing as we move along in x. So think that and we are going to graph it, but I'm going to graph it at the same time just for this example. And we're going to do even more slope next week. But think that as we work one more hour, our graph is going to go up $15 because every hour equals $15, okay? So I'll talk more about how I graph this in a second. Okay, so I'll talk about how I graphed it in a sec. But we figured out that X was our hours and Y was money. And we're trying to figure out how we draw the equation. And what we know is that for every hour we go, so if we start at 50, because 50 is what we had in our bank account, we're going to go up $15 every time we work an hour, okay? So that would be how we graph it, but that's why 15 is going to be our slope, okay? And hopefully that makes sense to everyone. Hopefully that's pretty much review. But the slope is going to be 15. And then the second thing that it asks us is the y-intercept, okay? And y-intercept is where we start on the graph. It's what happens when x is equal to 0. Okay, so if we're doing this kind of graph, it's actually easier to understand this. But think that if we work 0 hours, the 15 and 0 are going to cancel out. So what would be left over? And that's whatever is in our bank account, even if we don't work. So it's 50. Okay, so the y-intercept here is going to be 50. So if I'm going to write this equation, that's what it's going to be. And these word problems are not going to be too tricky. I'm not going to give you too much extra information. So make sure you're just kind of thinking logically through it. Okay, so that's our equation. And now let's just talk about the graph. And I'm going to erase this, but when we're not doing a word problem, this is the kind of graph we're going to deal with, right? And then we'll graph it. We'll usually scale it by like ones or stuff like that, okay? But if you're talking about a word problem, you should probably graph it using just these axes and choosing the scale. So we know it exists here and here, and some word problems might have negatives, but if it's a traditional question talking about positives, we're mostly going to be in the first quadrant, and you need to be specific about where you're going with your scale, okay? Because we couldn't just go up one and have it work, because we're like this equation, the numbers are a lot bigger. So work on your scale, and I hopefully don't think I'm asking you to do too much with this lesson, but you can definitely let me know. But once you have the scale, the graph itself should be a little easier. Okay, so you're plugging in points into this graph. Sorry, it's a little late. My voice is kind of raspy. But once you know what the slope means, which means how much you're going up each time, just like yesterday, the graph itself should be pretty easy to draw. And this could go infinite depending on how many hours you work. But if you're not working a lot, this is more like a single shift. But we could extend this to like 30, but the relationship would be the same. Okay, so that's the graph. And then we just have two pretty easy questions to go over before we talk about example number 2. So it says E is how much money will you have if you work for 4 hours? Okay, so we could look at the graph and make an estimate, and depending on how accurate our graph is, it could tell us. But what's even better is we can just use the equation. Okay, remember that this is just saying that the amount of money you have is equal to 15 times the number of hours you work plus 50. So if it's saying how much money will you have if you work 4 hours, let's just plug in 4 here, okay? And these word problems are mostly there so that you are always thinking about what these things mean, okay? So here we plugged in the 4, and that means we're gonna make $60 plus the $50 we already had in our wallet. So we'll have $110. And then for F, we're gonna go the other way. So usually X is the input, right? But if we know that there's a relationship between both, we can plug something into Y and then solve for X, which involves a little bit more algebra. But for F, it just says, if you have $200, how many hours did you work? So it's saying that we have $200. We have to figure out how many hours we worked if we have $200. So we'll just have 200 in for Y. And then whenever you're trying to solve for a variable, remember that you're just trying to isolate it and move everything to the other side. Okay, so this is just a simple linear equation. And if X is here, we want to first move the constant over this way, and then we can divide by the coefficient. And that's like some Algebra 1 or earlier stuff. But if you ever get confused on the order of how to get rid of stuff, you want to usually get rid of what's farther away first. That's usually a good trick. So this X and 15 are really close knit. They're connected to each other. But the 50 is a little farther away. So move the 50, and then it's 150 divided by 15, and that's just going to be 10. So that's math that we can do without a calculator. Okay, so that was that example. I thought it was pretty cool. And for the second example, it's going to be very similar, but we're given slightly different information, so we'll talk about the second form we have. Okay, but that's kind of the base of what we're doing. Okay, so we're going to do number 2, and all the word problems are going to be very similar to each other, so don't worry about that. But they're going to be not just in and out, because my second example is in and out again. But you have to be very careful on what's given to you. So this time it says you work a part-time job at In and Out, which pays you $13 an hour, 13 and a half. After working 8 hours, you have $140 in your bank account. Using this information, answer the questions below. So it says that you're getting paid $13.50, so we already know that that's going to be the slope of this. But it says after working 8 hours, we have $140 in the bank account. So it doesn't tell us the y-intercept. So first, all of these are going to ask us to name the variables, and these are the same. For the sake of time, we're doing the similar stuff. So x is hours worked, and y equals money. But if we're trying to create the equation, it says we want to use the point slope form, which is y minus y1 equals mx minus x1. And let me write that down. Okay. So what we were talking about last time is that we have two forms for an equation. We have y equals mx plus b, which is more famous, I would say. But this form, called the point slope form, is just as valid, and we can use it if we're given a point and the slope. Okay, so here we don't have the y-intercept. We don't have the plus 50. We don't know how much money we have in the bank to start. But we do know that the slope is $13.50, and we also know that after 8 hours we have $140 in the bank, so we have a point. So we don't necessarily need the y-intercept. As long as we know a single point on our graph, we can put it into this form, and then we can graph, okay? So all I have to do is plug in x1 as 8 and y1 is 140. So that's the point, and there's only one of each of these. You keep the x and the y, but you get rid of the x1 and the y1. So that is the equation. And it doesn't look nearly as pretty, and we're going to actually talk about how to convert it to the other form. But if you needed to graph, it works because we have those two things, okay? So for D it says to graph, and let's do that graph again. I kind of messed up, I didn't give myself a lot of room here, but let's just go up like 20. And because I definitely wanted to get at least to 8, 140. And I hope I'm not going too fast today. Next week we'll slow it down a bit if we need to with the word problems. But I think it's kind of better this way. So we have this point, we have 8 and we have 140. And it works so much better if you have graph paper. So we're gonna get it. And then we know the slope is 1350. Okay, so if I was trying to be really accurate, I would show exactly what it is. But I'm feeling a little lazy about that. So I appreciate you, and I'm being a bad math teacher, but I'm gonna kind of estimate. So 6 should take us down like 27, so like around there. Okay. So that's my line. And I'm gonna be way more organized next week, I promise. It's so funny. Okay. It's more important we get the gist of this. So E now says, and this is the bulk of the stuff for the end of the lesson. This is the last big thing. It says, how much money did you have in your bank account before you started working? So we want to figure out pretty much what the intercept is, right? And we could bring our graph all the way down, but it wouldn't necessarily get us exactly what it is. Okay, so we're going to talk about pretty much 2 ways to do this, and the second one might be more generally useful. But first, this is our equation, and we're just trying to find the point. That's the y-intercept, which means that x is 0. So if we're trying to find this y value, all we have to do is plug 0 in for x and solve the equation. Okay? So that is a key, and we'll come back to that throughout this unit. But if I want to find one part of a point, we plug in the value for the other. So you can find any point if you already know what the input is, right? Because this is just what a table is. So if I plug in 0 here, it's going to be y minus 140 is equal to 13.5 times negative 8. So I think you'll be fine to just use your phone calculator in this class for now. But I'm getting y minus 140 equals negative 108, and then I add the 140 this way to get my y. So that is our intercept. Okay, so we intersected around 32, so the graph actually wasn't that bad. And we know that the point is 0, 32. And all that means is that before we started working in and out, we had $32 in our pocket. So the final thing it just says is to convert our equation into y equals mx plus b. So this is a skill that we would use even if we weren't using a word problem. And that's how can we turn this into y equals mx plus b. And all we're going to do is basically get y by itself. Okay? So we're going to first write this out, expand it, and see what that does. Okay, so if you ever need to rewrite this into y equals mx plus b, just think about it like it's an equation. We can rewrite this as 13.5x minus that times that, which we did for the last one, as 108. And if I bring this over here, we have y equals mx plus b. Okay, so hopefully everyone can see that. To go from here to here, all we did was undistribute this times this and this times this. Now if I move this over here, it's going to give us the equation. No. Okay, so this and this are the same thing, and this is really good for us because we already knew from the last question that the y-intercept was 32. Okay, so we found it in two different ways, but this is really useful because we took point slope form and turned it into slope intercept form. So there's a G and an H, but that's pretty similar to stuff we did before. So I'm going to end here. But really, really good work today, and finish this up by Friday. I'm probably only going to grade things later on Friday, not actually at noon. But I appreciate you for making it through the first week.